Right now, as you are watching this, hurricane forecasters at AccuWeather are using a phrase they rarely repeat 2 years running. They say they are, in their own words, very concerned about rapid intensification this season, the same concern they raised last year because the water sitting across most of the hurricane basin right now is exceptionally warm, not just at the surface, but hundreds of feet down. At the same time, nearly every major forecasting center, NOAA, Colorado State University, and AccuWeather among them, is calling for a below normal number of storms this year. Fewer storms and more concern at the same time sounds like a contradiction. It is not, and understanding exactly why it is not may be the single most useful thing you can learn this hurricane season. Today we are going to break down what scientists are actually watching, why a quiet season on paper does not mean a safe season in practice, and what the real data says about where the danger is actually concentrated. No hype, no exaggeration, just the forecasts and the reasoning behind them. Drop a comment and tell me where you live along the coast and whether you have started your hurricane preparations yet thy S-year. I read every one of these. If you want grounded storm coverage instead of panic headlines, subscribe. It is free. And A-like helps this reach the people who need to see it before a storm threatens them, not during one. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. Let us start with the official numbers, because they matter for understanding exactly what forecasters are and are not predicting. NOAA's outlook, issued back on May 21st, calls for a 55% chance of a below normal Atlantic hurricane season this year, with only a 10% chance of an above normal one. The agency is forecasting between 8 and 14 named storms total, of which 3 to 6 are expected to become hurricanes, and 1 to 3 of those reaching major hurricane strength, meaning Category 3 or higher. Colorado State University's most recent forecast, updated as of July 13th, actually reduced its numbers further from its earlier outlooks, now projecting total tropical cyclone activity at only about 40 to 45% of the long-term average, specifically citing increased confidence in a strong or very strong El Niño developing by the peak of hurricane season. AccuWeather's outlook similarly calls for 11 to 16 named storms, near to slightly below the historical average. Every major forecasting group is pointing in the same direction on raw storm counts, fewer storms than a typical year. The reason behind that consensus comes down almost entirely to one thing, the El Niño event we have covered in earlier breakdowns, which is strengthening faster than originally expected. El Niño increases vertical wind shear, the disruptive change in wind speed, and direction with height that tends to tear developing storms apart before they can organize, and that increased shear is expected to dominate the tropical Atlantic and Caribbean through the peak of this season. Historical data backs this pattern up clearly. Since the start of the satellite era in the 1960s, El Niño years have averaged only about 10 named storms and 5 hurricanes, compared to roughly 15 named storms and 8 hurricanes during La Niña years, and about 13 named storms in years when neither pattern is present. This year is shaping up to follow that same El Niño suppression pattern, and CSU's lead forecaster, Phil Klotzbach, noted that the current season is exhibiting characteristics similar to 2006, 2009, 2015, and 2023, all previous El Niño years with below normal storm counts. So if the storm count is genuinely expected to be low, why are forecasters simultaneously raising alarms about rapid intensification? Here is where we need to separate two things that people often assume are the same but are not: how many storms form, and how dangerous the storms that do form actually become. Rapid intensification, as defined by the National Hurricane Center, means that tropical cyclones' maximum sustained winds increase by at least 35 miles per hour within a 24-hour period, roughly 2 full categories on the Saffir-Simpson scale in a single day. Under normal conditions, this happens to only about 1 or 2 Atlantic storms per year, making it a relatively rare event. But the ingredients that produce rapid intensification are not about how many storms form in the first place. They are almost entirely about ocean heat content, specifically how deep the warm water extends below the surface, and El Niño's wind shear does not change that underlying ocean heat one bit. It just makes it statistically harder for a storm to organize past that shear in the first place. If a storm does manage to push through, it can still find an ocean prime to intensify it explosively. Alex De Silva, AccuWeather's lead hurricane expert, explained the specific concern driving this year's outlook directly. He said the water across most of the hurricane basin is exceptionally warm, and that this warmth extends hundreds of feet deep across most of the basin, which is exactly why AccuWeather is, in his words, once again very concerned about rapid intensification this upcoming season, echoing the same worry from the past couple of years. That detail about depth is the whole mechanism in a single sentence. A hurricane's own powerful winds normally churn up colder water from below, and that colder water rising to the surface acts as a natural brake on the storm's strength. when the warm layer extends far, enough down that brake essentially stops working because the storm just keeps stirring up more warm water instead of cooling water, removing the one mechanism that would otherwise limit how strong it can get. Last year's season gives us close to a perfect real-world demonstration of exactly this dynamic, and it is worth walking through in detail because it is the clearest recent evidence that storm count and storm danger are simply not the same variable. The 2025 Atlantic season produced 13 named storms and 5 hurricanes, close to a near normal year by raw count. And for the first time in a decade, not a single hurricane made landfall in the continental United States. On paper, that looks like a quiet, low-impact season. But according to Allianz Commercial's catastrophe risk analysis, 4 of those 5 hurricanes intensified all the way to Category 4 or 5 strength, one of the highest proportions of major hurricanes relative to total hurricane count in the entire Atlantic historical record. All 4 of those major hurricanes underwent rapid intensification. And despite the below-average hurricane count, the season's accumulated cyclone energy, a measure that captures both the strength and duration of storms across the whole season, still reached approximately 108% of the 1991 to 2020 long-term average. Hurricane Melissa, which arrived late in the season, was confirmed by NOAA as one of the strongest Atlantic Basin hurricane landfalls on record and caused an estimated $11 billion in economic damage across the Caribbean, despite the overall season looking mild from a distance. This is not a new or isolated pattern either. Forecasters and risk analysts keep returning to 1992 as the textbook historical example. That year produced only 7 named storms and 4 hurricanes, a genuinely quiet season by any measure, and yet it delivered Hurricane Andrew, one of the most destructive hurricanes ever to strike the United States. Analysts at Allianz Commercial put the underlying lesson plainly. Hurricane counts are a weak predictor of landfall and loss risk. What actually drives destruction is not how many storms form in a given year, but the intensity of the individual storms that do form and precisely where they happen to make landfall. There is broader data behind this pattern too, not just individual storm examples. According to Climate Central's tracking of Atlantic tropical cyclones from 1980 through 2025, 190 Atlantic storms underwent rapid intensification. And nearly 1/4 of those, 46 storms, did so at what scientists classify as an extreme rate, meaning sustained winds jumped by at least 58 miles per hour in a single 24-hour window. Perhaps the most striking figure in that entire data set concerns the storms that actually caused significant damage once they reached the United States. Of the 67 total billion-dollar tropical cyclones that have impacted the United States since 1980, 48 of them, 72%, underwent rapid intensification at some point in their life cycle. That is not a marginal correlation. It means that when you look specifically at the storms responsible for the most catastrophic damage in modern American history, rapid intensification was present in nearly 3 out of every 4 of them. It is worth being precise about where the actual heat is concentrated this year too, because it is not uniform across the entire Atlantic basin, and that nuance matters for understanding where risk is genuinely elevated versus where it may be somewhat lower than headlines suggest. The Cape Verde region of the central Atlantic, where roughly 3/4 of major hurricanes typically originate, is currently running below average sea surface temperatures according to this year's assessments, and storms that form in that specific region typically have greater potential to intensify simply by traveling over thousands of miles of open, warm ocean before ever approaching land. Cooler than normal conditions, they are one of the specific reasons several forecasting centers are calling for a below-average season overall. Meanwhile, the western tropical Atlantic, the Gulf of Mexico, and the Caribbean, the areas we discussed in detail, when covering Gulf storm risk earlier this month, remain warmer than normal, with that warmth extending unusually deep. That geographic split matters enormously for where this season's actual risk sits. Fewer storms may form via the classic long-track Cape Verde route this year, but any storm that does organize closer to the coastline, in the Gulf or the Western Caribbean, is moving through water that remains primed for the kind of rapid, late-stage intensification that leaves coastal communities with the least possible time to prepare. AccuWeather's own landfall risk analysis for this year, built by comparing current atmospheric patterns to past seasons with similar setups, specifically flags the northern and northeastern Gulf Coast and the Carolinas as the areas facing the greatest risk of direct impacts in 2026, based on how storms behaved in years like 2009, 2014, 2018, and 2023, each of which shared a similar broad pattern to what is currently developing. The risk along the Texas coast specifically is assessed as somewhat lower this year, though De Silva was careful to stress that lower relative risk does not mean the state is in the clear, since, as 1992 demonstrated, It only takes one storm finding the right conditions to produce a catastrophic outcome, regardless of the season's overall projected activity. There is one more storm worth mentioning here, not from the Atlantic, but from the Eastern Pacific, because meteorologists studying rapid intensification frequently point back to it as the single most extreme example on record, and a warning about how little time this phenomenon can leave for a warning to even go out. Hurricane Otis struck the Mexican resort city of Acapulco in October of 2023 after intensifying from a tropical storm to a Category 5 hurricane in under 24 hours, a jump so fast and so far outside what forecast models expected that official National Hurricane Center advisories were still calling for a much weaker storm mere hours before Otis made landfall as one of the most powerful hurricanes ever recorded along that coastline. Otis is not technically an Atlantic storm, and it is not part of this year's Atlantic outlook, but forecasters raise it constantly in discussions of rapid intensification precisely because it demonstrates the outer edge of what is physically possible when a storm crosses over deep, exceptionally warm water with almost no shear to stop it, and because it exposed real limits in how far in advance even sophisticated forecast models can catch this kind of acceleration before it has already happened. That gap between how fast a storm can intensify and how quickly forecasters can warn the public about it is exactly why NOAA has been investing heavily in new forecasting tools ahead of this season specifically. For the first time this year, NOAA is integrating data from small, uncrewed aircraft systems directly into its hurricane analysis and forecast system, and scientists at the agency's Atlantic Oceanographic and Meteorological Laboratory have found that incorporating this data can improve hurricane intensity forecast accuracy by roughly 10%. NOAA is also testing an experimental high-resolution seasonal forecast system built with the unified forecast system community, specifically designed to better capture the evolution of the global ocean atmosphere system rather than relying purely on historical averages. None of these tools can prevent rapid intensification from happening. What they are specifically designed to do is shrink the gap between when a storm starts to explosively strengthen and when forecasters can get a warning out to the people in its path, which, based on what happened with Otis, is precisely the gap that matters most. So what does all of this actually mean for you, wherever you are along the coast? The single most important takeaway is this: do not use a below normal seasonal forecast as a reason to relax your preparations. Have your evacuation plan, your emergency supplies, and your family communication plan ready before the peak of the season arrives in September, not after a storm has already formed somewhere off the coast. As De Silva put it directly, it is important that everybody from South Texas all the way to Maine prepares equally for every hurricane season, regardless of what the official seasonal outlook says, precisely because the data we just walked through shows that storm count and storm danger are simply not the same thing. Know your evacuation zone before a storm is approaching, not during the 48 hours before landfall. Pay close attention to any storm that begins showing signs of rapid intensification specifically, since, as we covered, that pattern has been present in nearly 3 out of every 4 of the most destructive United States hurricanes since 1980. And understand that a quiet look at the map with no named storm currently visible does not mean the ocean beneath that calm surface has stopped being capable of fueling something dangerous very quickly. It is also worth connecting this back to the broader pattern we walked through when we covered the developing Super El Niño earlier this month. The same strengthening El Niño responsible for suppressing this year's Atlantic storm count through increased wind shear is, at the same time, part of a global reorganization of ocean heat and atmospheric circulation that has already produced textbook rapid intensification conditions elsewhere this year, including the explosive strengthening we covered in Super Typhoon Bavi in the Western Pacific. That is not a coincidence of unrelated events happening to occur in the same season. It reflects the same underlying reality showing up in 2 different ocean basins at once, an atmosphere being reshaped by a major El Niño event layered onto record global ocean heat, suppressing storm formation in some places through added wind shear, while leaving the ocean itself just as primed, or in some basins even more primed, to intensify whatever storms do manage to form despite that shear. The honest, grounded summary is this: every major forecasting center is calling for a below normal number of Atlantic storms this year, driven primarily by a strengthening El Niño increasing wind shear across the basin. That part of the forecast is genuinely reassuring if you only look at raw storm counts. But the ocean beneath that shear, particularly in the Gulf of Mexico and the Western Caribbean, remains exceptionally warm and unusually deep in that warmth, which is exactly the combination that has fueled rapid intensification in a growing share of the most destructive storms on record. Last year proved this dynamic in real time, a near normal storm count that still produced one of the highest proportions of major hurricanes in Atlantic history, all 4 of which intensified rapidly. Whether 2026 becomes known as a rapid intensification season will not be determined by how many storms the season ultimately produces. It will be determined by what happens to the handful of storms that do manage to push through this year's wind shear and find that warm water waiting underneath. We are going to keep tracking this as the season progresses toward its historical peak in September, sourced the same way we did today, straight from NOAA, Colorado State University, AccuWeather, and Climate Central, not recycled headlines. Subscribe so you do not miss it if a storm starts showing signs of rapid intensification this season, because based on everything when it happens. And leave that comment below. Tell me where you live and whether you already have your hurricane plan in place this year. Because behind every one of these forecasts is a family deciding whether to board up their windows a day too early or a day too late. And that decision is a whole lot easier to make correctly before the storm is already spinning up off the coast. 5,000 likes on this one. Let us go. See you in the next one.